Honeypots can imitate the behavior of vulnerable devices and be used to detect insider threats and attackers. Their main advantage is that they do not suffer from false positives and can even detect zero-day attacks. In this work, our goal is the fast and automatic deployment of honeypots inside a large network of multiple devices, such as an industrial infrastructure. Additionally, we aim to create unique profiles of services by utilizing open source honeypots to mimic the behavior of services inside an IoT setting and convince the attackers of the authenticity of the target. Example of profiles we can build can be a Windows server or an ICH node. In this demonstration, we will showcase the automatic deployment of the Kauri and Conpot honeypots through Helm charts and an attempt of an attacker trying to attack and its activity being recorded and reported. First, a little background. In this demonstration, we use Dockerized honeypots. That means that the honeypots we deploy are placed inside containers. Here we will see an example of a Docker Compose file for Compot honeypot. As you can see in the Docker Compose file, you can specify the ports which the container will expose and also set some environment variables. Also for Gauri Docker Compose, we can see the ports that we expose. In order to manage and automate those Dockerized honeypots, we use a Kubernetes cluster. First, we have a server called master, which through specific YAML files give instructions for each honeypot to run on a slave. Those YAML files can be combined into one package called Helm chart. We have created a Helm chart for each honeypot we use. The advantages of combining Helm charts with Kubernetes are that we can achieve fast deployment, we can make configuration changes fast and effortless, and also we can manage the health of each container more efficiently. We use Helm charts for Compot, Kauri, and also for FileBit, which we will get the logs that the honeypot produce and send them to our dashboard where they will be displayed. Now I will show you an example of a chart. Next, I will show you an example of Compot and Kauri Helm charts. As you can see here, we have Compot chart and Kauri chart. Each Helm chart consists of many YAML files. The most important in our case is the deployment, values, and service file. As we can see, in the values YAML file, we specify the image of the honeypot we use, the type of service, load balancer or node port, the IP where the honeypot listens, the name of each service we want to use from honeypot, the container port that the Docker exposes for the current service, and the port that is exposed in the outside world. Now, in the deployment file, we fill the name of each service, the protocol, and the container port that expose the service. Also in the service file, we specify the IP and the port which accepts the traffic and redirects it to the container port called target port. This information is provided by the values file, as we can see here, for example, this path, which gets the container port from the values file. from here. Next, I will show you how simple it is to deploy a Helm chart and especially honeypot k8s chart. I'm from master node and I just typed this command and the k8s chart now is deployed. Also, we deploy and the honeypot chart. Now, to see that this works, we just get the pods, and as we can see, we have honeypot and kauri ready and running. Before I show you a demo with an attack and the logs, let me tell you first about the two honeypots. First, honeypot is a low interaction ICS honeypot. It can emulate various vulnerable services which are common in IoT settings such as Modbus, SNMP, HTTP, and others. It offers logging capabilities and can report intrusion events. Kauri is an SSH medium interaction honeypot which can emulate the SSH and the telnet services. If the attacker manages to connect, it can emulate a Unix system and can detect and report the attacker's behavior. Now I will show you the first demo, which is an attack to Kauri honeypot using SSH. I will open two terminals. On the left side, this terminal will show the logs that the Kauri will provide, and on the right side, this terminal will try to attack. We start with SSH. As we can see, immediately it starts logs that someone trying to SSH, and after inserting a password, we can see that we are inside the Unix system, and the Kauri is taking the attacker's IP and informations. If I type a command, for example ls, immediately we can see that the Kauri stores what command I executed. Also, we can see the attack in our dashboard. Here we can see that there was an attack from Greece, and the protocol was SSH, the IP was that, and the city. Now I will show you a second demo where we attack the honeypot honeypot now, and we will do that using nmap. First, we go and see the logs of honeypot. Okay, and now we see that. So we open nmap and we run an attack on port 21. Let's see now the attack. As we can see, it starts logging that someone is trying to attack. And now if we go to our dashboard and select onboard, we can see that there's been attacks with protocol FTP, which is right because we attacked only port 21 where's the FTP license, the country, and the IP. So